Hello everyone. Today we are going to solve the April shift to 8th April paper, and it is JEE Mains paper basically. We are solving the math section here. So let's get back to the questions without wasting any time. Now the question one is, consider the relation R on the set defined by AB belongs to R. AB is the part of the relation and the condition is given by AB greater than -1. So we have to solve it. Now we have to write it again. We have to take A from here and B also from this. So I am writing it again. So we will not fall into the trap of calculation mistake. Okay. So when we are creating the relation R, it will be like, put, first of all we select -2 and -2. When we are multiplying -2, it will become 4. So the relation is true. -2 -1 again true. -2 comma 0 again 2 because we will get 0. -2 into 1, it is wrong because -2 2 we will not take this. Now we are moving to -1 comma -2 -1 comma -1 -1 comma 0. Now if we are taking -1, it will not be true because -1 into -1 will give to -1, which is wrong. -1 is cannot be greater than -1. So now we are moving to 0. Again 0 comma -2, it will be true. 0 comma -1, 0 comma 0, 0 comma 1, 0 comma 2. We have to solve the questions by cool mind only. So 1 comma -2, it will be wrong. 1 comma -1, it will be wrong. 1 comma 0, 1 comma 1, 1 comma 2, and now the last one is 2. We are taking it to -2, it will be wrong. 2 comma 0, 2 comma 1, and 2 comma 2. So when we count these numbers, this will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So it is true that the relation has 17 numbers. Now coming to the equivalence relation, when we check the symmetricity is there, it is symmetric because by the definition of symmetric, if AB is greater than -1, then BA is also greater than -1, which is true. But it is not it is not transitive. It is not transitive. We are seeing -2, it will be -2 a square. Again we are having 0 0 -1 -1 2 comma 2. But for transit, it is not transitive because if AB is greater than -1 and we are given that BC is greater than -1, this implies here you see AC is not greater than -1 for every number, not greater than. So it is not transitive. So it is not the equivalence relation. Here the answer comes out to be only one is true. So let us quickly move to the second question because we have to solve the paper quickly. Yeah, see the on option only one is true. Now we are moving to the second question. The number of the values of the z belonging to this, again what, this is a complex number. We have taught earlier that this is a circle with center 4,8 and radius 8, radius root 10. So the radius is root 10, center is 4,8, and the second one is, yeah, z minus 3 plus 5 iota plus z minus 5 plus 11 iota equal to 4 root 5. So this is a ellipse whose focus are given by 3,5 and S2 is given by 5,11. Yeah, and its length of major axis will be given by 4 root 5. Here are the informations given. We have to solve the number of values satisfying these two. Means we have to find geometrically that whether they are touching each other, cutting each other. We have to find this. Yeah, so we can draw a rough figure for that, but for that I need the values of ellipse of eccentricity. So eccentricity will be 2AE, that is the distance between the two focuses, and the distance between the two foci is given by root of 5 minus 3, 2 square 4, 11 minus 5, 6 square, that is 36. So it will come out to be 40 root, means it will be 2 root 10. And 2a is given by 4 root 5. So e, and e will be coming out to be 2 cancel root 10 by 2 root 5. So it will like e equals to 1 by root 2. Okay, we can calculate this easily, and we have calculated that easily. So what about the semi major axis, semi minor axis of ellipse? Let's get to the formula of ellipse. B square by a square, eccentricity, it is 1 by 2, 1 minus b square upon a is 2 root 5. So when we square it, 4 into 5, 20. So b square comes out to be 1 by 2 into 10, 20. So b will come out to be root 10. So it is clearly seeing that the semi minor axis and r are equal. And what about the center? We are drawing the rough figure only. So I am drawing the center here of the circle 4, 8. And you can see the midpoint of this is also the center of circle 5, 11, the focus, and second one is 3, 5. This is a rough diagram. We are taking 4, 8 as origin. So what about the a2 root 5? A2 root 5, and about this, the ellipse is given by this. The ellipse is given like this, and here it is root 10. So now get back to the circle. Its radius is root 10. We can see where root 10 falls. Root 10 falls here, and the circle will be like somewhat, it is 5, 11. Yeah, I am taking it and rubbing it because the figure may not be, looks like a ellipse, looks like a circle. So now this is the circle. So we can clearly see the circle is touching the ellipse at 2 points only. So the value of z which satisfy both these two is this first point and this second point. These 2 points will satisfy both the equation. So number of solutions will be given by 2. We can see, we will provide you also the PDF in this description section of this video. Yeah, see, the answer is 2. Now coming back, we are coming to the third question. If the system of linear equation is given by this and it has infinitely many solutions, then we have to find the value of lambda plus nu. So for infinitely many solutions, we know that the determinant, I think you know the Kremlin's rule, and Kremlin's rule was given in the determinants of the class 12th, where we studied that for infinite solutions, delta 0 and delta x should also be 0, delta y, delta z 0. Then the equation will be having infinitely many solutions. So I am taking only these two deltas. Let us find the delta. How can we find the delta? Delta is the determinant of all the coefficients of x, y, z. So in this first, x coefficient 1, y 1, x coefficient 1, y coefficient 2, 5, 2, 3 and lambda. This should be 0. So 1, I am solving it, 2 lambda minus 15 minus 1 lambda minus 10. Let's hope that the calculations will not be wrong. So I am again cross checking it, 2 lambda minus 15 minus 1 and this will be lambda minus 10. Again the last one is 3 minus 4, 0. Yeah, it's correct. So it will be lambda minus 15 plus 10 minus 5 minus 5 minus 1. So lambda equals to 6. Coming back to the lambda x. Now let us go to delta x. Delta x will be what? We have to remove the coefficients 1 of x, 6, 2, 5, minus 6, minus 10 and 3 lambda minus mu. And we have already found out the value of lambda, so I am replacing lambda by 6. Okay, and why it is minus? Because we have shifted these towards the left hand side. So 1, we are solving the determinant. Students, 5 minus 5 nu plus 60. Okay, minus 1 minus 2 nu plus 30, minus 6, 12 minus 15 minus 3. So we are calculating it, minus 5 nu minus 3 nu plus and 5, 60 minus 30 plus 30 plus 30 plus 18 plus 48 equals to 0. So nu will comes out to be 16. So lambda is 6, nu is 16. We have solved it, lambda plus nu, 6 plus 16, that the answer is 22. Okay. Now we are going to the fourth question. Here again it is a simple problem of determinants. Again it is a calculation based problem, but we have to solve it now. Whether it is calculation based or whether it is direct, we have to solve it. So again I am writing A. The matrix is given by alpha 1 2. This is the second, 2 3 0 0 4 5, and B is given by this adjoint of A, this plus adjoint of A. So we have to find first adjoint A, otherwise we will be getting it quite hardly. And determinant of adjoint of A is given by determinant of A ki power n minus 1. Since this is a 3 cross 3 matrix, so determinant of A square will be the answer. Means we have to find this determinant of A square. For determinant of A square, we have to find alpha. So what about adjoint? What is adjoint of A? Adjoint of A, as you know, the transpose of the cofactors is known as adjoint. Transpose of the cofactors. What is cofactor? First we are taking alpha. The cofactor will be 15, and we have to also put the minus 1 plus 1. We will put it, then 1, 10, 2 cofactor will be 4 to the 8, and now 2's cofactor again, this go, 5 minus 8 minus 3, 5 alpha, then last 4 alpha. Okay, now again it is 0. When we see, this is minus 6, this is minus 4, 3 alpha minus 6. There was less space, so I have written it here. And we have to put the minus plus, that was minus 1 power I plus j, plus minus plus minus plus minus plus minus plus. So transpose will be adjoint of A. I am writing it completely here. 15, 3 minus 6 minus 10, 5 alpha, 4, 8 minus 4 alpha, or 3 alpha minus 6. So this is the adjoint A. And what we have to find out? B. B, we can write it here, B. B is 1 0 0 0 minus 5 alpha 0 0 4 alpha minus 2 alpha. So this is B plus adjoint of A. What is adjoint of A? Adjoint of A is, we have written again, 15 3 minus 6 minus 10 5 alpha 4 8 minus 4 alpha 3 alpha minus 6. So what will be the final outcome of B? B will be 1 plus 15 16, 0. We are adding it. You know the addition and subtraction of the matrices. I think so. That's why I am doing it directly. Minus 10, it will be 0. it will be 4, it will be 8, it will be again 0, it will be minus 2 alpha plus 3 alpha, alpha minus 6. So it is B, but basically what we have given, determinant of B is 66. So let us see that the two columns are here 0. So determinant of B will be minus 3. This will be minus 3 plus minus, hiding the rows and columns corresponding, minus 10 alpha plus 60. Okay, and minus 32. And this is 66. So we can find it minus 10 alpha plus 28, that is equal to, whether when we divide it by minus 3, it will be minus 22. So alpha will be 50 by minus 10 minus 5. Alpha is given by minus 5, and I think the question has been solved now. By putting alpha equal to minus 5 here, we can easily find out the determinant of A, and the determinant of A will be, let us write here, A equals to 5, 1, 2, 2, 3, 0, 0, 4, 5, minus 5. So the determinant of A will be, you can find it minus 5 by putting 15, 0, minus 75, that will be equal to 21. And determinant of A square will be given by 441. So it is correct. We have found it easily again. You can also check it, 15 minus 75 minus 1. Yeah, okay. So let us go to the third question. Fifth question. Yeah, we have came to the fifth question so quickly. Now the fifth question is given by alpha equal to 3 plus 4 plus 8 plus 9, 13, up to 40 terms. Okay, then 10 beta ki power alpha upon 1020 is a root of this equation. Okay, this is the root of this equation. Beta belongs to 0 to pi by 2. So we have to find this one. Sin square beta plus 3 cos square beta. So let us find out alpha first. See the pattern here. It is when you add these two, it will be 7. When you add these two, it will be 17. When you add these two, it will be 27. So when you are clubbing two terms, then it go up to 20 terms. You can find the sum of this AP. The AP sum will be come out. What is the sum of AP? N by 2, 20 by 2, 2A plus N minus 1, 20 minus 1 into D. So it comes out to be 2040. Right. So coming back to this equation, this will be 10 beta power alpha upon 10T0 means 20. This will be 10 square beta. Means 10 square beta is satisfying this equation. So we can find out the x from this equation. Minus 1 plus minus under root b square minus 4ac upon 2. That will come out to be minus 1 plus minus 3 by 2. So 3 minus 1 to 1 and minus 2. Since beta is given in between 0 and pi by 2, so we will have to reject minus 2 because it is negative. In the first quadrant, 10 beta is positive. So 10 square beta equals to 1. The condition is given that this is the root. So 10 beta equals to 1, beta equals to pi by 4. Beta equals to pi by 4. So when you put beta equals to pi by 4, this will be sin square 45, 1 by 2 plus 3 into 1 by 2. So answer will be 2. See, the question was also easy again. The main problem was here in the pattern, which we have to observe it. Otherwise the question was easy. Let us see. Yeah, answer is 2. Yeah, this is the question of probability. And what it is about Bayes theorem. Have you studied the Bayes theorem? I think so that you have studied. I have the full confidence on my students that they have studied the Bayes theorem. So let's get back to the question. What is given here? A candidate travels to the exam center by bus. The probability of going by bus is 2 by 5. Going by scooter and going by car are given here. Probabilities of being late means he is late. The student is late given that he traveled by bus is 1 by 5. Student is late traveling by scooter S, it is 1 by 3. Late by car 1 by 4. I hope this is clear. And we have to find out given the candidate was late, the probability he traveled by bus means we have to find out the candidate was late and he traveled by bus. We have to find this. So this is a reverse probability Bayes theorem. For Bayes theorem we have to find out the total probability of late, or upon, and the favorable case that he was traveled by bus. So total probability we have to find the total late probability. How can we find the total late probability? Probability of getting late by bus, late by this. So first find out the probability of traveling by bus into probability of late when traveled by bus, and plus probability of scooter, probability of late by scooter, plus probability of what? Car, late traveled by car. So this is the total probability of getting late. When we calculated, probability of bus is 2 by 5, late is 1 by 5 bus, probability of scooter 1 by 5, getting late is 1 by 3 by scooter, probability of traveling by car is 2 by 5 again, and late by car is 1 by 4. So we can find it 2 by 25 plus 1 by 15 plus 1 by 10. We can see it, the LCM will be 150. So 150, 12 plus 10 plus 15. It will be 37 by 150. Okay, it will be 15, 27, 37 by 150. Now we have to find this, and this is given by in the Bayes theorem that probability of late by bus into probability of bus upon total probability of getting late. Okay, so probability of late by bus is what we have given, 1 by 5. Probability of traveling by bus is 2 by 5 upon 37 and 150. This is the total probability. So it will be 5 2 by 6 into 37 and 6. So it will be 12 by 37. I was doing it carefully because these are the main points what I want to show you, that when I am calculating I go slow. The same is expected from you people, that you should go slow. I can solve fastly, but it will not be in favor of you because I want to show you how to calculate in the paper. So that's why I always go down, my speed goes down when I am solving the final answer. If you have any confusion, you can write it cleanly on other side of the paper and you can solve it, but do not do wrong, because this one step can ruin your 4 answer, 4 plus 4. In fact, it will give you -1. Okay, we are going to the next question, that is 26 2 की power 3. Yeah, this is a pattern again. Okay, this is a pattern again. 3 की power 13 minus alpha is the sum, and we have to find the value of alpha. So first of all, we have to write the general term. Can we write the general term? Yeah, definitely we can write the general term. It is 26 bracket sigma r equal to something, I will see it later. It is 2 to the power 2r plus 1. Why I have written 2r plus 1? It is 3, 5, 7, so it is a odd number. Again 3, 5, 7, odd number 2r plus 1. And it is 12c, it is even number 2r. So let us put r equals to 1. If you put r equals to 1, it is 3 to the power 3, 2c2. First you will get, second time you will get by taking 2, and by how much it will be, it will go up to 6. So this is the general term. Hope this general term is clear to you, and this was the main point. We have to move to the next point, next step. This is the formula we have seen, NCR upon R plus 1, that is N plus 1 CR plus 1 upon N plus 1. Here what is N and what is R? In this, N is 12 and R is 2R. So we can rewrite it again, 26 sigma R equals to 1 to 6, 2 to the power 2R plus 1, and this is 13 C 2R plus 1 upon 13. So 13 will be divided here. Okay, we can see it clearly. Now it is 2. So when we expand it again, we can find it easily that the terms are like, we have to solve by very cool mind. Otherwise we will get into the trap and we will get the wrong answer. It will be when we expand it 13c3. Yeah, it is coming out to be 13c3 when we are putting r equal to 1, 2 to the power 3, 13c5, 2 to the power 5, up to 13c13, 2 to the power 13. We have to find the sum of this. And we have seen earlier that I will give little bit of the clue that when 1 plus x power n, it comes out to be nc0 plus nc1x plus nc2x square up to ncnx power n. And when we will solve, you see that we are missing the even terms here, even c1. So when we use 1 minus x power n, it will be nc0 minus nc1x minus plus nc2x square up to last. So when we are putting here 2 in both the equations, you will see, you will get n is, so here we are getting this expression. We have to solve it by this idea. 1 plus x power n, we know that this is the simple expansion 1 plus x power n, this is again the expansion 1 minus x. So when we are putting, we require 2 here to put. When we are putting 2, it will come out to be n value 13, it will come out to be 13c0 plus 13c1 what 2 की power 1 plus 13c2 2 की power 2 dot dot dot. When we are putting here 2 again, it will be minus 1 power 13 equals to 13c0 minus 13c1 2 power 1 dot dot dot. So how we get this? We get this by subtracting these 13 power 13 minus of this, so this will be plus 1. So 2, when we are subtracting, even will get vanish, even terms will get vanish, and we will get 13c1 twice 2 plus 13c3 2 power 3 dot dot dot. Exactly what is written here, but with the exception this is not here. So the final answer will be what? We have to put this to the left hand side, 13 power 3 power 13 plus 1 minus 2 into 2 into 13C1. Let it see here, when I am putting this to the right hand side, sorry, left hand side, what we are getting exactly this equation. So this is our final answer, 3 power 13 minus 51. So the value, this is the value of alpha, what we are written here, it is 51. So again, it was a lengthy question because the calculation was lengthy, not because the concept was lengthy. So let us quickly move to the next question. See, answer is 51. Yeah, again, this is a simple question, and a person, we have to first read before us commenting anything, that whether it is simple or whether it is tough. A person has 3 different bags and 4 different books. The number of the ways in which he can put these books into the bag so that no bag is empty means it is a simple case of division and distribution. First we have to divide it, divide the books into the bags, then we have to redistribute it. So let us see, there are 3 boxes. So how can one box not be empty? No box should be empty. Let us say I am putting the one book in the first bag, one book in the second bag, and in the third book I am putting 2. I can also juggle in between these, the 2 in this, 1 in this, 1 in this. I can form many pairs. So this is the division. And in how many ways we can divide? Number of divisions. Divisions is given by generally factorial n. Factorial n. How many are there factorial? How many books? 4 different books. Factorial 4. This is the first bag, factorial 1. This is the second. This is third. We have the 2 identical bags, so I have to divide by factorial 2. The number of ways coming out to be 6. And the distribution will be what? I have to distribute in how many? 3 bags. So the distribution will be 3 bags, means it will be factorial 3. So 6 into 6, it will coming out to be 36. This was a simple case of division and distribution. First we have divided it by factorial n upon factorial 1, because there was first one book only, second there was one book only, and in third it was factorial 2. 2 bags were identical. That's why we have divided by factorial 2, and this was the division, but the distribution can be in these 3 bags, so it can be done by factorial 3 methods. So it will be 36. Let us go to the 10th question. If a straight line drawn through the point of intersection of 4x plus 3y minus 1 equal to 0 meets the coordinate axis at point P and Q, then the locus of the midpoint of PQ. So what we are given, that 2 straight lines, their point of intersection, they meets at the coordinate axis. So how can we find the line which is passing through the point of intersection of these 2? We can find it easily by L1 plus lambda L2 equal to 0, family of lines which represents the line which is passing through the point of intersection of these 2 lines. So let us see, the line will be 4x plus 3y minus 1 plus lambda 3x plus 4y minus 1 equals to 0. So 4 plus 3 lambda x plus 3 plus 4 lambda plus minus 1 minus lambda equals to 0. So this is the line which is passing through the point of intersection of these 2 lines. This line meets the coordinate axis at P and Q. We have to find the locus of the midpoint of P and Q. So what will be the point P? This line is somewhat like this, cutting x-axis at A, cutting y-axis at B. So we have to find the point A. Basically A point lies on x-axis, so we have to put y equals to 0. Y equal to 0, we will get x 1 plus lambda upon 4 plus 3 lambda, comma 0. And what about B, the point on y-axis? We have to put x equal to 0. So x equal to 0, we will see 1 plus lambda upon 3 plus 4 lambda, 0 comma. So this is a point on y-axis, this is the point on x-axis. We have to find out the midpoint. So h equals to, the midpoint of these two will be a plus b by 2. So this will be 1 plus lambda upon 3 lambda plus 4 by 2. K will be 1 plus lambda upon 3 plus 4 lambda by 2. So it will be 2h equals to this one and 2k equal to this one. So what we are seeing that, I can write it directly. What we are seeing that 1 plus lambda are equal. So we have to reverse it. 1 by 2h will be given by 3 lambda plus 4 upon 1 plus lambda, and 1 by 2k equal to 3 plus 4 lambda upon 1 plus lambda. When we add these 1 by 2h plus 1 by 2k, it comes out to be 3 lambda plus 4 lambda, that is 7. 1 plus lambda upon 1 plus lambda. So we are cancelling it. We can simply write that 1 by 2h. 1 by 2h means 1 by 2x. We have to replace h and k by x and y, and this is 7. So the answer is x plus y minus 14xy. So this is the right answer when we solve it. Again, we have solved the question with very easy steps. What was given in the question, we solved it by that steps only. So we are again moving to the next question, 11th. Quickly to the 11th question, because we have to sum up this mathematics paper. Let O be the vertex of the parabola y square equal to 4x, and its chord OP and OQ are perpendicular to each other. Okay, the chords are perpendicular to each other. We will draw the diagram to explain the same. If the locus of the midpoint of the line segment PQ is a conic section C, then we have to find the lattice rectum of the conic section P. Means we have to find out the midpoint locus. So let us draw the diagram. Y square equal to 4x. Here P and Q, OP is perpendicular to OQ. So P is parametric point T1 square comma 2 T1. Q is T2 square comma 2 T2. This is the parametric point. This is O. This is perpendicular, means the slope of OP and OQ. MOP into MOQ will give you -1, and by putting it, the slope of 2 by T1, first one, 2 by T2, that is -1, means T1 T2 will be given by -4. Is it okay? So we have to find the midpoint. Locus of the midpoint. So that is RH comma Q. So the midpoint will be given by H equals to T1 square plus T2 square upon 2, and K equals to 2 T1 plus T2 by 2. So K is this, H is this. H equals to T1 plus T2 whole square minus 2 T1 T2 upon 2. Okay, we are placing the values. H equals to K equal to T1 plus T2, so K square minus plus 8, because it is -4 upon 2. So Y square equals to 2x minus 8. This is the curve, 2x minus 4. So this is the length of lattice rectum 2 of the given conic, and this is the answer. Okay, basically we have to find out the locus. So the locus was this, y square equal to 2x minus 8, and the length of the lattice rectum is given by 2. Now moving to the question number 13, we see first we will have to read the question. Fx is given by e to the power sine mod x minus mod x. X belongs to real number. F is differentiable. It is clearly wrong for x belongs to real number because we know that mod function is not differentiable on roots. So for mod x is equal to 0. It is the root of this mod x. So the mod x is not clearly differentiable at x equal to 0. So this function is also not differentiable at x equal to 0. We can also see by the full procedure of LHD, RHD, but here we are seeing it clearly. So we need not to solve LHD and RHD. In the second option, f is increasing. We have to see it whether it is true or false. For this one, this is basically the 0 minus pi by 2 minus pi. This is basically this quadrant. 0 minus pi by 2 minus pi minus 3 pi by 2 like this. So we have to see it. This is e to the power minus sin x. In this quadrant sin is negative and mod x it will also be negative, so plus x. So when we differentiate it for getting strictly increasing or decreasing, f dash x will be like e to the power x minus sin x, because the differentiation of this will remain same, into 1 minus cos x. Here the cos x is negative, in this third quadrant it is negative, so the overall quantity will be positive. So f dash x is greater than 0. F dash x is greater than 0 because this quantity will be completely positive. This is positive, multiply, this is positive. So it is overall positive when f dash x is 0, fx is strictly increasing function. So it is correct. Statement 1 was false, statement 2 is correct. This is wrong, this is right. So let us move to the question number 14. This is somewhat misprinted. Here it is given a vector is this one, b vector is tan I cap plus 2j cap minus k cap, c vector is a vector which is given by the definition to a vector cross b vector plus 2b vector cross c vector equals to 0 vector, and again a vector dot c vector are given by 15. C vector dot this is equal to what we have to find is c vector basically. So let us write the equation to a vector cross b vector plus 3 b vector cross c vector equals to 0. Okay, let us write to a vector cross b vector minus 3 c vector cross b vector. We can write to a vector minus 3c vector cross b vector equals to 0. Okay, I hope these steps are clear. Very simple steps of addition and subtraction. By this we can see that this vector cross this vector equal to 0 means these two vectors are parallel. So 2a vector minus 3c vector equals to lambda b vector. Okay, so we can find it c vector equals to 2 by 3 a vector minus lambda by 3 b vector. I hope this is clear. I have just twisted the sides, this gone here, this gone here. So 2 by 3 lambda by 3 all okay. Okay, c vector is this one. We have found the c vector 2 by 3 a vector minus lambda by 3 b vector. Lambda is arbitrary scalar what we have chosen by the definition of a trouble us. A vector dot c vector. C vector is 2 by 3 a vector minus lambda by 3 b vector. Okay, and that is equal to 15. This sounds more good. 2 by 3 a dot a is what? Mod a vector square minus lambda by 3 a vector dot b vector equals to 15. So by this mod a vector will be 16, 9, 20, 16 plus 9, 25 plus 1, 26. So it is 26 by 3. Okay, minus lambda by 3. What is a vector dot b vector? 40 minus 2, 38, 38 minus 3. So now we have to calculate lambda. This is lambda by 3 into 35 equal to 15, 52 by 3 minus 15. Okay, side have been twisted. 45, 45, 7 by 3. So lambda by 3 into 35 is given by 7 by 3. So lambda is given by 1 by 5. So it is lambda. Now we have found the lambda. We can easily find out the C vector, that is 1 by 5, 15. Okay, now what we have to find out? C vector dot this one. So C vector is basically 2A vector minus lambda by this. So C vector I am writing it here, 2 by 3 A vector minus lambda 1 by 15 B vector. Okay, we have to find C dot this one. So here this is C vector, and C vector dot I cap plus J cap will be given by, I am writing it here, C vector dot I cap plus J cap minus 3 K cap, that is equal to C vector 2 by 3 A vector minus 1 by 15 B vector dot I cap plus J cap minus 3 K cap. Okay, now we have to solve this. When we put A vector here, when we put B vector here, we will get the answer. Let me solve first. 2 by 3 A vector minus B vector by 15, C vector I cap plus J cap minus 3 K cap. So it will be 2 by 3, 4, 4, this will come out to be minus 5. Okay, you can solve it quickly. You can use the dot product. Okay, we have solved this 14th question also. Now this is the question number 15. Let the foot of the perpendicular lambda 2 comma 3 on this line be the point 1 nu 2. Okay, foot of the perpendicular, the distance between the line this and this is equal to. So we have to first find out the given situation. The line is given by x minus 4 upon 1 equal to y minus 9 upon 2 equal to z minus 5 upon 1. Okay, so the point lambda 2 comma 3 is given here. Let the foot of the perpendicular this on this line, on this line is this, the foot of the perpendicular 1 nu comma 2. Okay, then the distance between this is lambda nu, these are given. So basically what we are seeing, that this point satisfies this line, and we have to find the DRS of this line first. So DRS are lambda minus 1 comma 2 minus nu comma 1. Okay, these are the DRS, and when these DRS are multiplied by this, we will get 0 because these two lines are perpendicular. This is the foot. So lambda minus 1, the DRS of this multiplying 1, the DRS of this 2, 2 minus nu, the DRS of this 1 and 1 equals to 0. So basically the equation came out to be lambda minus 2 nu minus 1 minus 1 plus 4, 3 plus 1 minus 1 plus 4, 3 plus 1 4. This is basically the equation of lambda and nu. Now we have to find what? We have to find also the distance between these two given lines are parallel. So we have to find this nu, and this we know that this point is lying on this line. Basically this satisfies this line. So when we put 1 minus 4 minus 3 equals to nu minus 9 upon 2 equals to minus 3. So the value of nu from here comes out to be minus 6, nu equals to 3. Okay, when we put nu equals to 3, it will be minus 6 plus 4 equal to 0. So lambda equals to 2. So lambda equals to 2 and nu equal to 3 are the two values we were looking for. Now we have to find the distance between these two lines. Basically these two lines are parallel, and let us rewrite these again. X minus 1 upon 2 equal to y minus 2 upon 3 equal to z plus 4 upon 6. Okay, and the second line is x minus 2 upon 2 y minus 3 upon 3 equal to z plus 5 upon 6. So basically what is the distance formula between the two parallel lines? If two lines are parallel, then the distance formula is given by a2 vector minus a1 vector cross b vector upon mod of b vector whole mode. This is basically the formula for the distance between the two parallel lines. What is b vector? 1 minute. B vector is given by the direction ratio. So B vector is 2i cap plus 3j cap plus 6k cap. What is A2 minus A1? A2 minus A1 is basically the point on this line is 1, 2, minus 4, and the point on this line is 2, 3, minus 5. This is A1 vector, this is A2 vector. So basically A2 minus A1 will be, A2 vector minus A1 vector will be, let us see, 2 minus 1 I cap, 3 minus 2 plus j cap, minus 5 plus 4 minus k cap. So this is A2 minus A1. Putting in this, we have to find out A2 minus A1 cross A2 vector minus A1 vector cross B vector. First we will find it separately. So by the cross product, I, j, k, 2, 3, 6, 1, 1, minus 1. So it will be I cap minus 3, minus 9, minus j, minus 2, minus 6, plus k cap, 2, minus 3, minus 1. Okay, this is A2 minus A1 cross B. And what is mod B? Mod B vector is given by root of 36 plus 9 plus 49. This is 7. And the mode of this will be given by mode of A2 minus A1 cross B vector is given by under root 81 plus 64 plus 1, that is 65, 146. So the answer is root of 146 upon 7. Okay, see how cool we have solved it. Just we are focusing on the calculation. We have to focus on the calculation very much. We can slow down while calculating. If you are not going slow while calculating, it guarantees your mistake. So please be very careful while solving the numericals, especially when you are in the counting section. Means you are counting like 1, 2, 3, 4, you are writing root 146, root 7, like this. You have to go very slow at that phase, because that phase is very critical for solving the question. Now moving to the question number 16. What the question number 16 says, this is given. So quickly we know that 0 to 2, this is given by x square plus x plus 1, we know, and this is x square minus x plus 1. It is an integral based question, classical IIT JEE question. Okay, when we are cutting it, we will see root x dx. Here it will be root x plus 1. It will be like root of x square minus x plus 1. Okay, are you seeing something? This is a plus b, this is a square minus bab plus b square. This is what? A cube plus b cube. So again I am writing it root x dx upon this is root of a cube plus b cube. Okay, This is root of a cube plus b cube. And now what we are seeing here, this is root x. So what we can see it, we can clearly write it again, 0 to here, this is root x. So we have to find here the cube, we have to make something which will become the differentiation of this should become root x. Okay, so 0 to 2 root x dx upon, we have to write it x power 1 by 2, 3 by 2 and 2 plus 1. Okay, now you see when we are cutting, it will become again x की power 3. So let x power 3 by 2 equals to t, 3 by 2 x की power 1 by 2 dx equals to dt. So we can change this limit also when x equal to 0, t equals to 0, when x equal to t, 2 power 3 by 2. Okay, and when this is root x dx, it is 2 by 3 dt upon, this is under root t square plus 1. Now that's all. We know the formula of dx upon x square plus a square root. What is this? The formula is log of x plus root of x square plus a square. So we are implementing the formula. This will be 0 to 2 raised to power 3 by 2, 2 by 3 dt upon root of t square plus 1. 2 by 3, the formula is ln t plus root of t square plus 1 x square plus a square, and putting the limit 0 to 2 raised to power 3 by 2. So 2 by 3, when we are putting ln 2 raised to power 2 by 3 by 2 plus 2 cube 8, 3, 2 cube 8 plus 1 9 or minus 0. So you can see clearly this can be written as ln 3 plus 2 root 2. So the right answer is this one. Okay, so again this was the question of manipulation. If we know the formula of a cube plus b cube and we can click at the given time, we can solve this question very easily. And especially we have to also know the formulas of the integration, otherwise it will not be possible to solve in one go. Now this is a question of differential equation again. Y equal to yx be the solution of this differential equation. X cos inverse, x belongs to 0 to 1, y1 is given like this one, when x equal to 1, this is 1, y half is asked. Okay, so again we can write it, I am rewriting the equation. So y root of 1 minus x square minus x cos inverse x dx equals to 0. Okay, what we should do, we first write it as dy by dx plus y root 1 minus x square equals to x cos inverse x. You have just this side, this here, and now we are dividing by this one, the coefficient of dy by dx. So it will be y upon x equals to cos inverse x upon root of 1 minus x square. So this is the equation we finally found. Now this is the linear equation, and a linear differential equation, we know that we have to find the integrating factor first. Integrating factor will be e की power p dx. This is p is 1 by x dx. We need not to explain here the linear equation because the question will then go very long. So if will be integrating factor. Let us write the linear differential equation, py equals to q, then its solution is given by, I am writing it for the sake of your convenience, y into integrating factor equal to integration q dx plus c, and here we have to also write if. multiply if. I am writing it here. Okay, so it will be e to the power ln x. So x is the integrating factor. X is the integrating factor. Then we can find the solution here. How? 1 minute, let me show you how. Here the solution is y into if x equals to integration cos inverse x into if x upon root of 1 minus x square, and here dx plus c. Okay, now we have to integrate it. For this we have to take cos inverse x equals to t. Now we are moving to the next page. Let cos inverse x equal to t. So x equals to cos t. So dx equal to minus sin t dt. Now put in the equation y into x equals to integration cos inverse x, we have to put t, x we have to put cos t upon root of 1 minus x square. 1 minus x square means it is sin t into dx, we have to put dx equal to minus sin t dt. Okay, so let's cancel this. Y into x, it comes out to be minus t cos t dt. This is somewhat longer question because it is of the linear differential equation, and here the integration is also by the parts. First we have substituted, so it goes somewhat longer. Y into x, this is second function, this is first function. So by integration by part, first as it is integration of second sin t minus integration differentiation of first integration of second sin t dt. Again y into x is given by minus t sin t, and this is minus cos t, minus minus plus, again this is minus cos t plus c. So this is our final integral answer. So we have to put y into x, what is the value of t? We have to put it minus cos inverse x into sin cos inverse x into this, now minus x plus c. Okay, so what we were given? We were given that when we put x equals to 1, somewhat lesser than 1, x y equals to 1. This is the condition. So when we put x equal to 1, y equals to 1, minus cos inverse 1, cos inverse 1, sin cos inverse 1 0, then it is 0 minus 1 plus c. So c equals to 2. Okay, so the final value yx comes out to be minus cos inverse x sin cos inverse x minus x plus 2. Okay, this is the final equation coming out. Now what we have to find out? Y half. Y half, calculating it, y into half equals to minus pi by 3, because cos inverse 1 by 2 is pi by 3, cos pi by 3 root 3 by 2, and this is plus 3 by 2. We are multiplying it by 2, so it will be minus pi by root 3 plus 3. So the answer will be 3 minus pi by root 3. Okay, 3 minus pi by root 3. We have found the answer. This was quite a complicated, not complicated, so it was a lengthy question. So if we are doing the question and we are seeing that we are getting in the trap of calculation, or we have a fear that calculation may go wrong, so then we should avoid it. Otherwise we can done it easily. So we can do it easily. Okay, now moving to the 18th question. 18th question is given by fx equal to x minus 1 upon x plus 1, f iota plus 1 equals to f iota 1. I is given by 1, 2, 3, 25. It is I. And f1x equal to fx. We are given that gx plus f की power 26 x equal to 0. X belongs to 1 to infinity. Then the area of the region bounded by the y equal to gx, 2y equal to 2x minus 3, y equal to 0, x equal to 4. This is again a lengthy question, not the difficult one. So let us solve. Fx is given by this. We are given this I equal to 1. When we put I equal to 1, f2x, we will find out fx. Okay. Fx is given by x minus 1 upon x plus 1. Okay. So when we put x minus 1 upon x plus 1 minus 1, when we put this x minus 1 upon x plus 1 plus 1, so it is minus x minus 2 upon 2x, so it is minus 1 by x. Okay. When we find f3x, it is f2x. So f2x is given by f minus 1 by x. So when we solve it, we putting it in place of x, we are putting minus 1 by x, minus 1 upon minus 1 by x plus 1. So minus of 1 plus x upon minus 1 by x minus 1, so 1 minus x. Okay. When we find f4x, this is f3x. So we are seeing that it will be again f of x. When we put this is clearly seeing that when we put x plus 1 upon x minus 1, and this will come out fx. So f has period equal to 4. The period of fx is 4, means it will repeat after every 4 cycle. We came to know this. We know f square x. We know everything now. So what we have to find out? This one. So let us go. Gx plus f power 26x. The period of fx is 4. So when we divide it by 4, it will remain out only f square x, because the period fx will go on repeating. So it will come out to be f square x when we divide it by 4. So 24, 2. Okay. It will be 2. X belongs to 1 to infinity. Now gx, f square x was given by minus 1 by x. So gx equal to 1 by x. Okay. Now we have to find the area bounded by the curve y equal to 1 by x, 2y equal to 2x plus 3. So this is y equal to 1 by x. This curve is like this. The curve 2y equal to, so x equal to 0, y equal to minus 3 by 2. X equal to 0, y equal to minus 3 by 2. Here what I am doing, I am drawing this line. Okay. This line is when I am putting x equal to 0, y equal to minus 3 by 2. When I am putting y equal to 0, x equals to 3 by 2. 3 by 2 somewhere around. So the line will be like this. I am doing it by green. Okay. This is point of intersection. Point of intersection we will find out. X equal to 4 also. X equal to 4 we will draw by different color. Let us take this color. This is x equal to 4. Okay. This point, what is this point? This is y equal to 1 by x, and 2y equal to, this line is 2y equal to 3x minus, 2x minus 3. Okay. So when we put y equal to 1 by x, we can solve it easily. So putting y equal to 1 by x, 2 by x equal to 2x minus 3. So 2 equal to 2x square minus 3x, 2x square minus का 3x minus 2 equal to 0. Here we see what are the roots. 4 means minus 4 plus 1. minus 4, 4 comma minus 1 upon 2 upon 2 means it will be 2 because it is in the first quadrant. X equals to 2, y equals to 1 by 2. This is the point. We have to find out the area. So here are the two, first this area and second is this area. So we can find out it very easily, we can find it. This is the line, so first area A1, this is A1. Okay, A1 is integral of x equal to 3 by 2 to 2x minus 3 upon 2 dx. Okay, this is the area first. So we can solve it. X square by 2, 2 cancel, 2, 3 by 2 minus 3 by 2 x, 3 by 2 2. Okay, so this is the first area, 4 by. So now move to the calculation. We can calculate it by 1 by 2. This will be 2 square 4. Okay, this is 3 by 2 whole square, 9 by 4 minus 3 by 2. This is 2 minus 3 by 2. So when we calculate it, it comes out to be 1 by 8. Okay, and what about this part? This part is area A2. This is area A2. So integral of 2 to 4, 1 by x dx, because this curve is 1 by x. So it will come out to be ln x 2 to 4. ln 4 means 2 ln 2 minus ln 2, that is ln 2. So the total area will be 1 by 8 plus ln 2. Okay, so we can see the answer is 1 by 8 plus ln 2. It is correct again. Now we are moving to the question number 19. This is again a mix of continuity and integral. So first we have to solve this continuity. Less than pi by 2, it is 1 by 3, greater than. So if it is continuous, then LHL of fx should be equal to RHL of fx. Okay, we need not to use f of pi by 2 because we can fulfill our condition only by LHL, RHL. What is LHL? LHL is given by, LHL is 1 by 3, x less than pi by 2, and RHL we can find it by limit x tending to pi by 2 be 1 minus sin x upon pi minus 2x ka whole square. So when we are putting limit h tending to 0, it is pi by 2 plus h. So limit h tending to 0, we can write it pi by 2 plus h because the value of x is greater than pi by 2. So b, when we put pi by 2 plus h, this is the second quadrant. In second quadrant, sign is positive. So this is 1 minus cos h upon pi minus 2h. Okay, so it will be 4h square. Here this is 4h square. We can rub it for the clarity. It is 4h square. Okay, now we can see it. B, this one. We can use L'Hospital rule for the simplicity. Limit h tending to 0. This will be b into sin h upon 8h. Okay, so sin h by h is 1. So the limit is b by 8 by the L'Hospital rule. Sin h by h, again when we differentiate, it is cos h upon 1, or else it is a well known identity. When sin x upon x, limit x tending to 0, it is 1. So the answer is b by 8. So b by 8 by the definition should be equal to 1 by 3. So b equals to 8 by 3. Okay, now what is 3b by 6? 3b minus 6, it will be 8 minus 6, answer is 2. So we have to find the integral 0 to 2. What we are writing, 0 to 2, it is x square plus 2x minus 3 mod dx. Here we have to find out the roots of this equation so that we can know where it is positive and where it is negative. It is plus 3 minus 1. So it is minus 3 plus 1. By the way, it is negative here, positive, positive. So basically it is 0 to 2, means it will be break out into 0 to 1 negative and 1 to 2 positive. 0 to 1 it will be negative and 1 to 2 it is positive. Okay, we can now easily solve it. So just try to solve. Minus, this is x cube by 3, 0 to 1. Okay, this is x square by 2, so x square 0 to 1. This is minus 3x 0 to 1 plus, in this bracket we will solve it, x cube by 3, 1 to 2 plus x square 1 to 2 minus 3x 1 to 2. Okay, so minus, this is 1 by 3 plus 1 minus 3 in the first bracket. In the second bracket, 1 by 3, this is c, 2 cube, 8 minus 1, 7 by 3. Okay, 2 square 4, 4 minus 1, 3, this is 3, only minus 3. So 4 by 3 minus 3. Yeah, now we are calculating this. Minus 4 by 3 plus 3 plus 7 by 3. Okay, we have to write it very carefully. 7 minus 4, this is 3 by 3, 1 plus 3. So the answer is 4. Okay, so the answer is 4. This is quite right. Answer is 4. We are moving to the question number 20 now. Quickly to the question number 20. Let us read out the question. Let this function represents an ellipse with major axis along y-axis. Major axis means it is a case of b greater than a. Okay, this is a ellipse. Standard ellipse is given by this one, and b is greater than a. This is the ellipse with major axis along y-axis, where f is strictly decreasing function. F is a decreasing function if the set of all the possible values is given by this alpha square plus beta square. This is a simple question. This requires only the basic of function. So what we are given here, we are given f of 3a plus 15 is greater than f of a square plus 7a plus 3. We know that if a function is a strictly decreasing function, then if this is greater than, this one should be lesser than this. So 3a plus 15 should be less than a square plus 7a plus 3. Let us explain something for this. If fx is a strictly increasing function, then this equation prevails. And for decreasing function, let x1 is greater than x2. Let x1 is greater than x2, and if fx is a strictly decreasing function, no need to write this, then f of x1 should be less than f of x2, and also vice versa is correct. So that's why here this greater than sign, for decreasing we have to change the sign. So a square plus 4a minus 12 is greater than 0. We have to find out the roots. A plus 6, a minus 2 greater than 0. So a belongs to r minus 6 comma 2. This is the answer. This is by the given condition. This is alpha and this is beta. Okay, so alpha square plus beta square given by 36 plus 4, that is 40. So it is a simple question and can be done in minutes, 1 minute or only 2 minutes, just by using the concept. Yeah, the sum of all the squares of the real solution of this equation, we are asked the sum of all the real solutions of this. So we can see the equation. We have to factorize it first. Log of x plus 1, the factorization of this will be given by, we can factorize it here, 2x square plus 5x plus 3 for the sake of our for our convenience. 2x square plus 4x. This is 3 to the 6 means this should be 2x plus 3x plus 3. Okay, 2x plus 1 plus 3 x plus 1. So the factor is like this: 2x plus 1, 2x plus 3, x plus 1. Okay, so 2x plus 3 into x plus 1 equals to 4 minus log of 2x plus 3 x plus 1 whole square. Now we can see log of AB. This is log of AB, means log of A plus log of B. Okay, and log of x plus 1, same base, same power, same base, same exponent. This will come out to be 1. Log of 2x plus 3 plus log x plus 1 x plus 1. Again 4 minus 2 log of 2x plus 3 x plus 1. 2 coming out here by the property of log. We can see it. Let log of 2x plus 3 x plus 1 equals to t, then it is again automatically 1 by t. Okay, this is 1 by t because the base and exponent has been exchanged, and by the property of log we know that log of ax equals to 1 upon log of xa. Here all logs should be defined. Yeah, it is the prerequisite condition. So it will be t plus 1 equal to 4 minus 2 by t. T square, this will be minus 3, minus 3t equal to minus 2. T square minus 3t plus 2 equal to 0. So t equals to 1 and 2 are the solution. So we can find out the solution here: x plus 1, 2x plus 3 equal to 1. We have to check the solution again also, otherwise there are the chances of getting it wrong. By the property of log, this will be x plus 1 power 1. So here x equal to minus 2. When we put x equal to minus 2, here, anywhere, the log becomes negative. So this answer is not acceptable to us. Now by the second we are writing here what 2? Log of x plus 1, 2x plus 3 equals to 2. So 2x plus 3 equals to x plus 1 whole square. By the condition of log again, here 2x plus 3 equals to x square plus 1 plus 2x. So x square equals to 2, x equal to plus minus root 2. Again we have to check whether minus root 2 is acceptable. When we put minus root 2, again it is not acceptable. It is not acceptable in any of the log. So x equal to root 2 is the only solution, and its square should be given by x square equal to 2, and its sum, again it is the single answer, so answer sum should be 2. Okay, the sum of all the real is equal to 2, so the answer is 2. Now we are moving to the question number 22. If this is given alpha, again this is a question of integration, a basic integration but lengthy one. Okay, so we have to check it. Quote A, quote B. Let this is A, this is B. Quote A, quote B plus 1. So we are given the formula. We should know the formula. Quote A minus B should be equal to quote B quote A plus 1 upon quote B minus quote A. Okay, let us say this is A and this is B. First, before solving, you have to calculate it, na? So quote a minus b, it will come out to be minus 2 pi by 3, a minus b. This is cot b cot a plus 1 upon cot b minus cot a. So 1 plus cot b cot a, cot b means cot of x plus pi by 3, cot of x minus pi by 3, that is given by, this will be minus and pi minus pi by 3. So this will be minus cot pi minus pi by 3. Second quadrant again cot in negative, so plus cot pi by 3 means 1 by root 3. Okay, cot pi by 3 is given by 1 by root 3. So it should be 1 by root 3 cot x plus pi by 3 minus cot x minus pi by 3. It should be the solution. And now we have to put this here. We need not to change the values pi by 6 to pi by 4. So we are writing it pi by 6 to pi by 4. We have to do these questions by cool mind. 1 by root 3, here write it down, cot x plus pi by 3 dx. Again there is minus, so write minus 1 by root 3. I am separating the integrals. This is pi by 4 cot x minus pi by 3 dx. Okay. So what is the integration of cot x? We know that the integration of cot x is ln sin x. So writing it on the next page or solving it here? Yeah, we can solve it here also. By the green pen, we can differentiate. So it is 1 by root 3 ln sin x plus pi by 3. Okay, it is pi by 6 to pi by 4. The interval, minus sign comes out, minus 1 by root 3 ln sin x minus pi by 3 pi by 6 to pi by 4. Okay, is it correct? Yeah, it is correct. So 1 by root 3, you have to write it pi by 4 plus pi by 3 means it is ln sin, when we are converting it into degree, it will come out to be 105 degree. When it is pi by 6 plus pi by 3, that is pi by 2, sin pi by 2 1 means ln 1 means it is 0, minus 1 by root 3 ln, this is sin 15 degree and minus sin ln 30 degree, because we have to write the mode here. This is mode, so it will be taken as positive. You know it very well, when we are writing log, we have to put the defined values. So it will be ln sin 30 degree. Okay. So let us go to the next page, and this should be 90 plus 15 degree, and it is the first quadrant, so it will come out to be 1 by root 3 ln cos 15 degree. Okay. Minus 1 by root 3 ln sin 15 degree. Okay. Minus minus plus ln, and root 3 is there. Yeah, definitely the root 3 is there. 1 by root 3. Again we see plus ln sin 30. What is sin 30? Sin 30 is 1 by 2. So 1 by 2. Okay. Now we have to treat this root 3 ln cot 15 degree. Why cot 15? Because ln a minus ln b is given by ln a upon b plus 1 by root 3 ln half. And now what we are given, the requirement is we should have root 3 minus 1 here. We should have root 3 minus 1 here. Okay. So it is cot 15 degree. When we put it 10. When we put it 10, 15 degree, there should be minus coming out, because we know that when we put it 10, 15 degree, 1 by 10, 15. So 10, 15 power minus 1, it will come out to be this, and this is ln 10, 15 degree. I hope you understand this, plus 1 by root 3 ln half. What is the value of ln 15, 10, 15 degree? 10, 15 degree is given by 10a, 45 minus 30. 10, 45, 1 minus 10, 30 root 3 upon 1 plus 1 by root 3. So when you see, it is root 3 minus 1 upon root 3 plus 1. It is 10, 15 degree. So 10, 15. So it is root 3 minus 1 whole square upon root 3 minus 1, it is 2. So minus 1 by root 3, it is ln root 3 minus 1 whole square upon 2 plus 1 by root 3 ln half. Okay. So when we are mingling this comes out to be minus 1 by root 3. I am taking minus here, so let me write it here. It should be minus, and this should be 2, because 2 raised to power minus 1, it will come out like this. So minus 1 by root 3 common, when we are multiplying it, this will comes out to be root 3 minus 1 whole square, because ln a plus ln b, ln a into b, so 2 will be cut by 2, so the final answer will be minus 2 by root 3 ln root 3 minus 1. And what we are given in the question, this same, so alpha should be minus 2 by root 3, and what we have to find it, what we need to find is 9 alpha square. So 9 alpha square is minus 2 by root 3 square, so that is 9 into 4 by 3, that is 312. So the answer is 12. Okay, again this was a simple problem but with a complex solution, because we need to know the formula of this quote A quote B, and this should be clicked only when we have a rigorous practice. If we don't have the rigorous practice, you will not able to solve the question. Now we are moving to the question number 23. Let a line L1 passes through the origin and is perpendicular to the line L2, L3. The line L1 is perpendicular to both these two lines. A belongs to integer, Z is a point, this is a point on L3 line at a distance of root 17 from the point of intersection of L1 and L2, then a plus b plus c whole square equals to. So what is the line L1? L1 is a line passing through origin, so it should be x minus 0 upon L, its direction ratios, y minus 0 upon m, z minus 0 upon n. Okay. Line L2 is given by, we are writing in the coordinate form, this is x minus 3 upon 1. Hope you know all these things. Y plus 1 by 2 equal to z minus 4 upon 2. L3 x minus 3 upon 2 equal to y minus 3 upon 2 equal to z minus 2 upon 1. Okay. So this is the line L1, L2, L3, and what we are given, this line is perpendicular to both L2 and L3, means the direction ratio of these two lines and these two lines multiply will give you 0. So let us write the direction ratio multiplied this L plus 2m plus 2n equal to 0. We know that when the lines are perpendicular, their direction ratios get multiplied and getting added equals to 0. We know this very well, and when we studied the vector 3D, we know this very well. Okay. So 2L plus 2m plus n equal to 0. Okay. So L upon 2 minus 4 minus 2, m upon 4 minus 1 3, n upon 2 minus 4 minus 2. So Lmn are now known to us. So the line L1 is given by x by 2. We can also put minus here, plus we can multiply minus. So y by minus 3 equal to z by 2. This is the line L1 given to us. This is L2 and L3. What we are given, if the point this lies on L3, this point is lying on line L3. Okay, this point is lying on the line L3 at a distance of root 17 from the point of intersection of L1 and L2. Means we need to find out first the point ABC. This is on the L3. So L3, on L3 this point should be like R. Put R here. The point on L3 will be 2R plus 3, 2R plus 3 and R plus 2. Okay, point on L3 is given by this. And what about this? The point of intersection of N1 and L2, it is at a distance of root 17 from the point of intersection of L1 and L2. So let us solve L1 and L2. This is say lambda 1, and let us say this is equal to lambda 2. Okay, so first x coordinate of this is given by 2 lambda 1, and x coordinate for the point of intersection, x coordinate of L1 should be equal to the x coordinate of L2. So it should be lambda 2 plus 3. Means the equation is 2 lambda 1 minus lambda 2 minus 3 equal to 0. Okay, this second equation minus 3 lambda 1 should be equal to 2 lambda 2 minus 1. So here it will be 3 lambda 1 minus plus 2 lambda 2 plus 1 minus 1 equal to 0. So we can solve it by cross multiply. Lambda 1 upon 1 minus plus 3 to the 6, lambda 2 upon minus 9 plus 2, minus 9 plus 2. Okay, 1 upon 4 plus 3. So lambda 1 equals to 1 and lambda 2 equals to minus 1. Let us first again see this. To check it, it is very important to check 3 plus 6. Okay, lambda 2 minus 9 plus 2 minus 7, 4 plus 3 7. So it is 1 and minus 1. It is correct. Okay, so we have to find out the point of intersection of L1 and L2. The point of intersection P is given by, put lambda 1 equal to 1 here. When we put lambda 1 equal to 1, the point is 2 minus 3 2. Okay, the point of intersection is 2, this one, and the point on the line L3 is this. This point and this point are at a distance of root 17. So let us find out on the next page what is the distance. 2r plus 3 minus 2. Okay, the distance will be 2r plus 3 minus 2 means 2r plus 1 whole square. 2r plus 3 minus minus plus 3, 2r plus 6 whole square. Okay, r plus 2 minus 2 means r square, and the square of the distance is given by 17 because we are given that these 2 points are at a distance of root 17. So square will be like this. So let us break it in the square formula. A square plus b square plus 4r, a square plus b square plus 24r plus r square is equal to 17. Okay, r square 4 4 8, 8 or 9 r square. 24 or 4, 28 r. 36 plus 20 equal to 0. Okay, so we have to find r. R is given by 28 means 18 plus 10. R is given by minus 18 upon 9 minus 10 upon 9. R equals to minus 2. So we have to find out the L3. and a should be integer. Here we are given a should be integer, means this should be integer. So r equal to minus 2 is only valid. R equal to minus 2 is valid. This is not valid because this will not give you the integer value. Okay. So this point will be minus 2. When we put minus 2, it is minus 1. It is minus 1 and it is 0. Okay. So a plus b plus c square will be given by a plus b plus c whole square is given by minus 1 plus 0 whole square means 4. So the answer should be 4 equal to 4. Okay. We have found this problem also. There was a lot of calculation. So we have to do it with very cool mind. We have to trickle down our speed so that our question may not get wrong. Okay. We have to do it very carefully. Now moving to the question number 24. We have to first read the question. X square plus y square minus 6x minus 8y minus 11 equal to 0 be a variable code C substance, means it is a case of homogenization. If the locus of the foot of the perpendicular drawn from the origin on the AB is this, so first we have to write this circle is this with equation 3, 4 center and radius equals to 6. So this is the circle, this is the code AB. Okay, this is the code AB, this is origin O, this is subtending 90 degree. So what we are given? We are given here that we have to find the locus of the foot of the perpendicular. So this would be h comma q. Okay, it is 90 degree. So the slope of this line is k by h. So the slope of this line should be minus h by k. Okay. So we can easily write the equation of this equation, this code first. So this would be y minus y1 equal to slope minus h by k x minus h. Because we have to homogenize it, we have to first find out this equation. So this should be ky minus k square equal to minus hx plus h square. So this is hx plus ky is equal to h square plus k square. So h upon h square plus k square, x plus k upon h square plus k square, y equals to 1. Okay, this is the equation of the code AB. We need to homogenize it with the circle. So let us homogenize. X square is already 2 degree, no need. Y square is already 2 degree, x is 1 degree. So we have to put it h x plus ky upon h square plus k square. Okay, we have to multiply it by 1. Minus 8y again hx plus ky upon h square plus k square. Minus 11, we have to multiply it by 1 square because this is a constant value, hx plus ky upon h square plus k square whole square, 1 square. So it is 0. Now we need to find it only. This is a equation of OA and to OB. This is the equation of OA and to OB, and the angle here it is 90 degrees. So the coefficient of x square plus coefficient of y square should be 0 by homogenization. So we need to find out coefficient of x square plus coefficient of y square equal to 0. Okay. So let us write the coefficient of x square. This is 1. X square coefficient we will find it here by minus 6h upon h square plus k square. Okay. This is coefficient of x square here, minus 11 h square upon h square plus k square whole square. This is the coefficient of x square plus coefficient of y square. I am writing it here. So again 1 minus का 8 k upon h square plus k square. Okay. माइनस 11 के स्क्वायर अपॉन, okay, this is equal to 0. Coefficient of x square plus coefficient of y square should be equal to 0. So we have to now write it again and rearrange. We are rearranging it. It is 1 plus 1 2. So we are next page. We have to write it very carefully. 2 minus 6h upon h square plus k square minus 11 h square upon h square plus k square whole square minus 8k upon h square plus k square माइनस का 11 के स्क्वायर अपॉन एच स्क्वायर प्लस के स्क्वायर का होल स्क्वायर इक्वल टू 0. ओके, वी हैव रिटन इट विद वेरी केयर. सो 2 माइनस 6h प्लस 8k अपॉन एच स्क्वायर प्लस के स्क्वायर. ओके, माइनस 11 एच स्क्वायर प्लस के स्क्वायर अपॉन एच स्क्वायर प्लस के स्क्वायर whole square equals to 0. So dividing by this we will get 2h square plus k square minus का 6h plus 8k minus 11 h square, ये this got cancelled. Okay, so this is the locus. Writing the locus and dividing by 2 we will get x square plus y square minus 3x minus 4y minus 11 by 2 means 5.5 equal to 0. So this is the required locus. Again it is a lengthy question, and what we need to find out, this is alpha beta gamma. So comparing with x square plus y square minus alpha x minus beta y minus gamma, okay, equal to 0. So alpha equals to 3, beta equals to 4, gamma equal to 5.5. okay, so what we need to find out, alpha plus beta plus 2 gamma. So alpha plus beta plus 2 gamma will be given by 3 plus 4 plus 11, 15 or 3 18. So the answer is 18. okay, so the answer is 18. Again this is a question with lengthy calculation. So this is the last question of JEE Mains, shift to April 20 JEE Main paper. Now we have moved to the question number 25. Question number 25 is, let f be the function given by log 2x, log 2 fx equals to this one, log 2. So this is a GP, okay, this is a GP, 2 plus 2 by 3 plus 2 by 9 infinite, multiply log 3 1 plus fx upon f of 1 by x. F of 6 is 27, and we have to find out sigma n equal to 1 to 10 f of n. That is the required value. So this is a AP. We have to find the sum of AP. Here A is 2, R is 1 by 3. So the sum of GP will be A upon 1 minus R. Okay, 2 by 3, 1 by 3. So it will be 2 upon 2 by 3. It will be 3. So the sum of AP will be 3. Log 2 3 dot log 3 1 plus fx upon f of 1 by x. Is it okay? So by the cyclic property, it will come out to be log 2 1 plus fx upon f of 1 by x. We know this property, na, base changing property. When this will be divided by 2, log 2 will be here, because the property is log of AB upon log of AC. So then that is log CB. This is the property. We have used it by moving it to denominator. This will come out to be this with the help of this property log 2 fx. So if bases are equal, then it will also be equal. So it is equal to fx equal to fx into f of 1 by x. I am directly multiplying it, f of 1 by x plus fx. And this is a well-known function where fx is given by x power n plus 1. Here f of 6 equal to 37. So 37 equal to 6 power n plus 1. So n equals to 2. So the function fx is given by x square plus 1. Is it okay? And now that's I think over. Sigma n equal to 1 to 10 f of n, that is equal to sigma n equal to 1 to 10 n square plus sigma n equal to 1 to 10 1. So it will be n plus 1 2n plus 1 by 6. And this is what? This is 10. So 1 square plus 2 square, 10 square. So n equal to 10. We have to put 10 here. 10 into 11 into 21 upon 6 plus 10. 2 3 is 6, 2 5 is 10, 3 7, 35 into 11 plus 10. 5, that is 85 plus 10. So the answer is 395. Answer is 395. Answer is 395. Okay. So that's all from my side. This was the very fruitful session for the solving JEE Mains paper of 8th April shift 2. We are now moving to the next series of JEE advanced papers. There we are solving 2025, 2024, all the maths papers, and we will also try to solve the physics papers there. So that's all from my side. Please like and subscribe our video, because we are doing very hard work for you people to understand the questions in the basic and the quick way, and there are no shortcut for success. Thank you.